Number 8. A sample of gas occupies 1,000 milliliters at standard pressure. What volume will the gas occupy at a pressure of 600 millimeters of mercury if the temperature remains constant? So this is a situation in which we're actually mentioning all the terms. Excuse me. We have an initial volume. We also have an initial temperature and pressure because the question tells us standard pressure, which is 1 atmosphere. It also tells us that the temperature remains constant. Well, here's the thing. If I initially set this up as the combined gas law, and I see that the temperature value, the denominator, doesn't change, that means that I'm essentially dividing both sides, not essentially, I am, dividing both sides by the exact same number. That doesn't change the overall value of the terms. You guys see how that works? So they don't tell us what the actual temperature is, but they just tell us it remains the same. So let's just assume it's 300 Kelvin, just for example's sake. Divided by 300 Kelvin. This side is also divided by 300 Kelvin. Both of them are being divided by 300 Kelvin. There's no overall change, so I can ignore them. Or for those of you who, your brain works really well with algebra, let's just assume that I was going to try to, I am going to try to solve for V2, right? Because it's what volume will the gas occupy? So V2, let's just assume that I need to get V2 by itself. That means that I would have to get T2 off of this side. I would have to move T2 to the left side of the equation. Well, since it's a denominator, I would multiply both sides by T2. And so that would cause this T2 to cancel. But, like I said, I would have to multiply the left side of the equation by T2 as well. Well, that means I'd have a T2 on the numerator and a T1 on the denominator. Well, if they're both the same value, I'm both multiplying and dividing by the same term, there's no overall change. So we can absolutely ignore the temperature term. And so once we do that and rearrange for V2, we have something that actually just looks like Boyle's law. V2 is equal to P1 times V1 divided by P2. And this is what we mean when we talked about in the lecture that when in doubt, use the combined gas law. When in doubt, use the combined gas law, because in this example, you'll see that temperature doesn't change, and you can ignore it. Right? You can cancel it out just fine. So once we have this rearranged structure, plug in 760 millimeters of mercury, right? Because it's standard pressure, which is 1 atmosphere, but my other pressure term is going to be in millimeters of mercury, so I'm just going to put this one in as millimeters of mercury, which would be 760. Multiplied by the 1,000 milliliters, all divided by the 600 millimeters of mercury. Calculator tells me 1,266.7 milliliters. Well, I only want 3 significant figures because of this pressure right here. So I'm going to round to this 6 right here. The 6 right behind it tells me to round it up. So 1.27 times 10 to the third milliliters. Again, if you simply wrote 1,270 milliliters with no decimal, that would also be correct, but you would not use a decimal.